Right. Now listen. Last week we discussed about quantum numbers. So today we have to discuss the recipe. First of all, there is a question. Last week I was about to explain what is screening effect or shielding effect. That's the question, right? So last week I started discussing this and I stopped in the middle, right? I started discussing this and I stopped in the middle. So how it starts? I told if there is a nucleus, right? Nucleus, is the nucleus, the positive nucleus. This positive nucleus, the electrons will move surrounding this positive nucleus. And when electrons moving surrounding this nucleus, I told you there are many children and only one child. I told that effect. If there is only one child here, the attraction between this and this is very high. But when there are orbitals, when there are orbits, okay, energy level. So this orbit, there is electron in this orbit. What will happen? When this electron want to have an attraction between this and this, okay, when the electron wants to have the attraction between this and this won't have the real attraction when they are, okay. So when there is a nucleus, and in this nucleus, whatever the attraction between nucleus and the electron, this is known as what we call for this nuclear charge. What we call for this nuclear charge. This nuclear charge occurring between what and what? Nucleus means actually the nucleus whom? The nucleus who is that? The proton. Okay, in the nucleus, the proton. Okay, in the nucleus, proton and the electron only having this what? Nuclear charge. Can understand? Alright. Then this is known as nuclear charge. But what is shielding effect? This electron won't feel the actual nuclear charge. Why? Because this electron will, but they will repel this electron. Why? Between this electron and electron, what is the thing there? Repulsion force, right? Between this and this, what they have? Repulsion force. Between this and this, what they have? Attraction force. They have attraction force. So you should understand what is repulsion force and attraction force. Because what they do, they repel them. Okay, they won't allow to feel the actual nuclear charge for this electron. So this is only known as what effect? Shielding effect. Okay. So in the next question, I write what is nuclear charge. Maybe I have here. Okay, what is shielding effect? We will know it. We have write everything. Right? Under question number 71. Right? The question number 71. Okay. And the question number 71. We'll write one by one. Right? Now, what we call for this, first thing I have to speak three things under this. Right? One is known as nuclear charge. Under this heading, I want to speak about three things. Number one is nuclear charge. You know what is nuclear charge? I told you. You know what is nuclear charge? What is nuclear charge? The attraction between the nucleus and the electron is known as, when you take the electron singly, right? When you take electron singly, so that is known as what? Nuclear charge. Right. Okay. Okay. Whatever the, so you should know what is nuclear charge, the attraction between the nucleus and the electron when taken singly without other electrons. That is only nuclear charge. Second one, effective nuclear charge. That is second. Effective nuclear charge. This is the other word. This word. Effective nuclear charge. One is nuclear charge, other one is effective nuclear charge. What you make a nuclear charge, I put Z. Nuclear charge, I put Z. Effective nuclear charge, I put Z E double F. The meaning is effective nuclear charge. Okay. What is this effective nuclear charge? Whatever this electron is feeling is the nuclear charge. The first electron closer to this one. So this electron will feel the actual nuclear charge. But what about the second orbit's electron? Will they feel the real nuclear charge? No, they won't feel the real nuclear charge. Okay. Because of other electrons, they won't feel the real nuclear charge. Whatever the nuclear charge they are feeling is known as effective nuclear charge. Right? Effective nuclear charge. Effective nuclear charge, I can write an equation like this. I can write an equation like this. And to explain you, ZEF mean, what does it mean? Effective nuclear charge is equal to Z mean what? Z nuclear charge, right? Z minus SE. Z minus SC. What is SC again? iPhone SC what do you mean by here? What is SC here? It's shielding. It's shielding effect. Shielding effect. So this should be the effective nuclear charge number, the nuclear charge minus the shielding effect. Okay. Right. So did you understand these things clearly? Right. Okay. So we'll write one by one beautifully. Then we'll make a build up. Like this. Right. First thing under that you can write a word nuclear charge. You can write a word called nuclear charge. Under nuclear charge, the hyphen and write. Hyphen and write. Hyphen mean and write. You can write in front of the nuclear, in front of the nuclear charge. You can write like this. The attraction force between the nucleus and the electron between the nucleus and the electron and an electron when taken singly without considering other electrons, without considering the other electrons. Now that part is okay. That is only nuclear charge. Now you should know what is a nuclear charge. It was a word. What is the word? we should go for this. What are the effective nuclear charge? You should know this fraction force and repulsion force, right? Okay. Then write the next point. Shielding effect. At the next point, shielding effect. Next point is shielding effect. Write the point like this. The inner electrons, the inner electrons, the inner electrons, the inner electrons, the inner electrons of an atom, the inner electrons of an atom. The inner electrons of an atom shield within brackets you can write shield within brackets you can write. Do not let the outer electron, do not let the outer electron to feel the actual nuclear charge, to feel the actual nuclear charge. Feel the actual nuclear charge. ඕක තමයි shielding effect කියලා කියන්නේ. So can understand right? The inner you can write as the next point. The inner electrons under shielding effect the inner electrons are known as co-electrons. The inner electrons are known as co-electrons. The inner electrons are known as co-electrons. C-O-R-E, co-electrons. Now just imagine this system. What is this? What is this atom? What is this atom? This atom is sodium. How you say sodium? I can write sodium. How you say sodium? Because there are 11 electrons in this. So it is sodium. Okay. So, and I didn't mention it's an ion. So there are 11 electrons in this sodium. So I can tell when the may set this set. This is known as co-electrons. This is known as what? Co-electrons. This is known as, what is this? This is known as outer electron. It's known as outer electron. Okay, when I make it, just write the co-electron and the outer electron. Where's that red one? Oh, yeah. Okay. Either. Vale. Right. Right. Now these things are okay. What is outer electron? What is co-electrons? Those are okay. And the other thing is what the attraction goes and the repulsion goes, right? And you can. So what do you think when they are going down the group? What might happen to the shielding effect? When they are going down the group, what might happen to the shielding effect? What might happen? It will decrease or increase. When you are going down the group, what happened to number of shells? Number of shells will increase. When number of shells increasing means shielding effect, what will happen? Will increase. What is shielding effect? Shielding effect means the connection between this electron and this nucleus, these electrons are shielding. So when the number of shells are increasing, then to feel the nuclear charge between this electron and this nucleus, what will happen? When there are more number of shells, it will increase. When the number of shells are increasing, shielding effect, what will happen? Will increase. Careful listen. Careful listen this part. When the number of shells increasing, okay, what will happen? Shielding effect will increase. What do you think when minimum question? So I told the Buddha now shielding effect is occur because of what? Occur because of the co-electrons or the inner electron scale. So if I tell something like this, where shielding effect will be there for adding same number of electrons. Will it affect the nuclear charge of this? Again, will shielding effect increase? If the same orbital's electron increase or not, if the same orbit's electron if it increases, will the shielding effect increase? Or shielding effect will increase? Or nothing will happen? The answer is nothing will happen. Yes, exactly nothing will happen. Actually, right, something will happen, but that is negligible. Again, there is a small shielding, very minute shielding. Very minute shielding. For example, now we'll say, for example, now you are a fighter, you are a boxer. Okay, you are fighting with many players, and when you come home, you are small kid, just 1 year old child. He is just hitting you like this. So what can you say about that? Is it painful? No, it's painful, mildly painful. But when you compare to the shots what you are playing, is it considerable? Then that is negligible. Now just imagine you are a person who is earning 1 million rupees. Person is earning 1 million per month. Someone is giving you a gift, one of your friends, 5,000 rupees gift. Cash, 5,000 rupees cash. So will it make a huge change in your life? That 5,000? But it's something adding for your amount, but still that is a negligible thing. Likewise, only because of this electron, if there is a statement like this in exam, because of the same shell's electron, because of the electrons added to the same orbital, shielding will remain constant. If there is a statement like this, you have to take that as true. But if there is a statement like this, because of adding of electrons in the same orbital, same orbit, their shielding will increase slightly, minimally. That also you have to take as true. There are certain places, or your boxer, your child is hitting you. Okay. So when child is hitting you, okay, if we are saying when child is hitting you, there is a pain. Wrong here you can take. Pain. But if there is a statement, when child is hitting, there is a minimal pain. You can take. That's true. No pain you was hurry. Minimal pain you was take up. Got the point? I'm talking about a very small, chukti child kid. Got the point? Is it understandable? Is it clear? So whatever the outer electron here, you can make if the same orbit, if the electron adds, okay, you can tell the shielding effects changes very minimal. But there is a very minimal change. I think A level is something that you have to answer according to the place. From next week onwards, we'll start writing papers. Papers, yeah. Start. Next week, another good message is there. We are starting our class at 4 o'clock. Start 7:30 miss karo. Good no? Problem? I know you don't have any problem with the timings. But next week we'll start at 4. We have a curve. Okay. So this is the thing what you have to understand. Then write like so when you go down the group, shielding will increase. So when you are going from left to right of the group, shielding remains constant. Shielding remains constant. Or shielding slightly increases. Slightly again. Cell IgA or T the higher part slightly near. Okay. You will join with him. If you want to sit alone, you can sit there. Yeah, whatever you wish. Join with him. Right. Okay. Go on, you can join with him. Don't want to join with him. Yeah, very kidding. Now, anyhow, when the update, did you understand? The basic clear? Clear? Then write like this. When going down the group, next point, under shieldings. When going down the group, no, same point under shielding effect. But you continue the shielding. When going down the group, next point. Again, third point, I guess. When going down the group, the number of shells will increase. The number of shells will increase when going down the group. The number of shells will increase. The number of shells will increase. The number of shells will increase. Therefore, the core shells will increase. Therefore, core shells will increase. Core shells, C-O-R-E. CORE, core shells. Right? Core shells will increase. The next point, the shielding effect also will increase. The shielding effect also will increase. So I said when you are going down the group kill, I said no. What do you mean by when you are going down the group kill? Meaning in the periodic table, right? The periodic table when you are going top to bottom, you can from lithium, sodium, potassium. So whose last electron has more shielding? For lithium, sodium, potassium. Potassium's last electron having more shielding than sodium and lithium. Understood? Then write the next point. When under same shielding, still how much shielding the when moving from left to right, 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 the shielding is constant. The shielding is constant. Or shielding will increase very dekai. Right? Two varies. Very English right now. Very understandable. I'm telling you. English grammatically maybe chemistry, right? Very okay, minimal, very minimal. The increase के लिए you want the increase very minimal amount. Very minimal amount. Even negligible. That's why the both statements are correct. Constant Q for okay. So always when you are going to choose answers, you have to select the best answer in MCQs. A problem in MCQ. You can't say exactly no, nothing will happen for this because of child's attack. You can't. Understood? And you remember when you're in O-level, when you're going to do sums, you take the height of the human is negligible. Height and it is there. It's negligible. Right? Okay. What you have to do? Now we have to still I will speak about effective nuclear charge. Between the nucleus and the electron attraction force, between the electron and electron repulsion force. මේක ලස්සනට. ඒක පැත්තකින් වගේ හොදන්න. No, still for this one, shielding effect it is again. Why is continue for effective? No, I just but when you're walking, someone came the light. It was so long. You came by walking. My difference. Right. Now the next one. What is next? Next is the next one is effective nuclear charge. What is effective nuclear charge? Now I told you effective nuclear charge. What is effective nuclear charge? The net attraction force faced by the electron, the outer electron, due to the effect of co-electrons, so due to shielding effect. Anyway, that's why I said we can say the effective nuclear charge as what? Effective nuclear charge is equal to the nuclear charge minus shielding effect. Right? Effective nuclear charge. So effective nuclear charge is something, effective nuclear charge is something. Then write effective nuclear charge. Next point, effective nuclear charge, you can write Z E double. Can you? Z should be up, E double F should be down. Effective nuclear charge. And the effective nuclear charge is at E double F. Effective nuclear charge. You write like this. Like this. The net attraction, faced by the electron, the net attraction faced by the electron from the nucleus, after the shielding from the nucleus after what did I tell after shielding effect. So is it always lower than nuclear charge? The effective nuclear charge, is it always lower than the nuclear charge? What you can tell about that? Yes or no? Should be. Yes is always. The effective nuclear charge faced by an electron is always lesser than the actual nuclear charge. Most of the time it is true. So, like which instances it is not true? First electron. The meat having no co-electrons to shield him. Right? And whatever the nuclear charge facing by this electron is the actual nuclear charge and the effective nuclear charge both are same. Okay. First orbital people, there's no co-electron to shield them. But for last electron, the last electron of all atoms, effective nuclear charge is lesser than the actual nuclear charge. That is true or false? That is speak to the. That is false. Why? Now I said last electron. The last electron of an atom's effective nuclear charge is always lesser than the actual nuclear charge. That is true. The answer. No, that is not true. Just imagine hydrogen's last electron. Where is hydrogen's last electron? There's only one electron. My last electron, first electron. If you are the one, they are the only child at your family. First child count, last child count, eighth Mohammed. Hydrogen. So for hydrogen, but even the last electron, the effective nuclear charge and the actual nuclear charge both are same. When you are studying Kuda, there are the ways how you should think. Because when you're doing A level, you should know to think, okay, the proper way. That is very important. Very important. What shall we do? Write like this. Okay, right? Effective nuclear charge. Did you write? We wrote the definition also, the effective nuclear charge. Okay. So my question is, when you're going down the group, means anything from lithium, sodium, potassium, barium, cesium, when you're going like this downwards, what might happen to effective nuclear charge? Will increase or decrease? What do you think? Okay. When you're going like this, sodium, magnesium, aluminium, silicon, from left to right when it's going, what is happening to ZESS? Will increase or decrease? What do you think? Will increase kilo or what do you? Others here. Answers to 9. Will increase, will decrease, will remain constant. Now I told you a thing also how you get the effective nuclear charge. I showed you. Okay, how you get the effective nuclear charge from nuclear charge minus shielding effect. Now think. Then answer to you definitely you should raise your hand. Increase, decrease, remain constant. Take a increase, second decrease, third constant. Why will last? Who are telling? Number 1, increase. Increase. Who are telling? Number 2, decrease. Who are telling? Number 3, constant. What number? Decrease. What? Now let's check. Whenever you want to check, you have to argue with this. Now we have this formula. We have this form. Now we have to argue with this. What is this? Z kila it is nuclear charge. Is that? මේක nuclear charge න nuclear charge ඒක nuclear charge where what will happen to nuclear charge when you are going left to right? Nuclear charge will increase. Why it is increasing? Because when you are going left to right, what's happening to them? What is the atomic number of this 11? Here 12, here 13, here 14. What does it mean? What does these numbers mean? The number of protons. That is the number of protons. What are we writing as atomic number of protons? Number of protons are equal to electrons. That is correct. But what are we writing here? Protons. So what's happening to protons? Protons mean the positive charge is what's happening to the positive charge? Positive charge is increasing. When positive charge is increasing, mean what will happen to the nuclear charge? Nuclear charge will increase, decrease, or fail. It should increase. Can you understand? Right? Then the number of positive charges increases, definitely the nuclear charge will increase. I got that. Is it clear? Right. Number of protons will increase, therefore nuclear charge will increase. I said now this is going from left to right in the same. What's happening here? Electrons get added to the same orbit. 11, 12, 13 was for same orbit it get added. What will happen to shielding effect? I said it will remain constant, if not slightly increase. What will happen? This is increasing the our increasing part is more. I said this is almost negligible amount shielding effect. Therefore, what you can say finally the effective nuclear charge. Therefore, it will increase. What the point? So when you are going from left to right, what will happen to the effective nuclear charge? It will increase. It will increase. Did you understand this? Then don't try to buy hard. If you try to buy it from left to right, effective nuclear charge increases. From left to right, nuclear charge increases. Okay. From left to right, shielding effect constant. If you try to remember like that, you'll forget that. So how many things to remember like increasing, decrease? So what you should know, you should know the logics. Why is it increasing? There are certain areas D-level syllabus you have to remember as it is. Can't argue there. But mostly we have logics. Is it clear for them? Is it going properly? Okay, don't confuse. Nicely get these things in an order. Right. When you're going down the group, just think about this. When you are going down the group, just think what will happen to the nuclear charge, what will happen to the shielding effect. What will happen to the nuclear charge? When you are going down the group, nuclear charge will increase. Number of protons are increasing, the nuclear charge also will increase. Shielding effect also will increase. So what will happen to effective nuclear charge? Increase. It remains constant. This is a value. This is only effective nuclear charge. This value also increasing. Minus this value also increasing. This value also increasing. Minus this value also increasing. Means what will happen to this value? Almost it is constant. Really it is constant. By make up earlier we'll say this value is, for example, we'll say some answer is for ZDF, something like this. We'll think this value is 10 minus. Earlier we'll think 8 kL, 10 minus 8 kL. Now we'll say this is also increasing. Now this is increasing to from 10 to 15. This is increasing from 8 to 13. Both are increasing, but ZEF remain constant. Can you understand that? So when you're going down the road, nuclear charge also increasing, shielding effect also increasing. Therefore, right, effective nuclear charge almost remain constant. In the way of your way, automatically always here. So now we have to write this. Right. So now Nankala is NY. We'll think, we'll see whether you can remember this. Now, what are the things we spoke? Nuclear charge. It work like this, no? Nuclear charge. Nuclear charge. Left to right. Top to bottom. Take it right. Left to right means left to right of the periodic table. Nuclear charge. Top to bottom. When you are going from left to right, what will happen to nuclear charge? Speed. Increase. When you come from top to bottom, that also increase. Because number of proton increases means the nuclear charge will increase. Read about it. Right. Read about C9. The 11 one multiplied shield. Shielding effect. What happened to the shielding effect? Again, if I put this left to right, top to bottom. Left to right, what will happen? Shielding. Will right, what will happen to the shielding? Left to right, what will happen to the shielding? Will constant. Left right shielding is constant. Constant here we can not change, same orbital electrons and but top to bottom shielding will increase. Right? Number of shells are increasing, therefore shielding increases. And don't try to buy hard. Maybe this is I am giving this chart, not to buy hard. To double check. Finally, effective nuclear charge. What will happen to effective nuclear charge? Effective nuclear charge. In a way, left to right and top to bottom. Okay. This will effective nuclear charge left to right and increase. Top to bottom. When the very is it clear? Right. What Akala will write for the effective nuclear charge. No. Let's try it like this. Let's write the overview. Write the overview. Okay, first we don't know what is effective nuclear charge. So then write a point like this. Effective nuclear charge can be given using the following formula. Effective nuclear charge can be given using the following formula. Can be given using the following formula. Use the formula. Following formula. And first of all, put the formula. Fine. Okay. So after the formula, you should write like this. When going left to right, when going left to right, when going left to right, right. When going left to right, when going left to right, when going left to right. Nuclear charge will increase. Nuclear charge will increase. Nuclear charge will increase. Nuclear charge will increase due to increment of protons. Due to increment of protons. Due to increment of protons. But shielding effect remains constant. 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 Therefore, you can no need to write effective nuclear charge here fully. You can write the DFF. Therefore, Z effective nuclear charge. I will tell effective nuclear charge, you write ZEF. Therefore, effective nuclear charge will effective nuclear charge will complete the sentence. Will now this one is increasing, this is constant. Therefore, effective nuclear charge will increase. Increase. Effective nuclear charge will increase. अरे देखा था आपने then this one effective nuclear charge will increase. So now you only should write for this one for the next one. When going down the group, when going down the group, nuclear charge will increase. Shielding effect will increase. Therefore, effective nuclear charge remains constant. Right. Is constant or slightly is constant or slightly might increase or decrease. Increase. What will be more actually? Shielding effect will be more, nuclear charge will be when they are going down the group. Mostly nuclear charge. And the nuclear charge is okay, but what happened to the distance also when they are going down the group? Distance also increase. Therefore, shielding effect is more powerful. Yeah, shielding effect is more powerful. Therefore, slightly effective nuclear charge can decrease. Both is increasing, but shielding effect is slightly put up very constant you are thari. Then slightly reduces or decreases. Because shielding effect is more when you're going down the more shells When you're going down the road, you can tell nuclear charge increases, shielding effect increases. Therefore, it can remain constant or slightly reduces. Can remain constant or slightly reduces. When going down the road, nuclear charge increases, shielding effect increases. Therefore, the effective nuclear charge is a DFF. The effective nuclear charge remains constant or slightly increases. No video. Huh? Slightly reduces, slightly decreases. I'm sorry. Slightly decreases. Slightly decreases. මෙන්න මේ කතාව දාලා මේ කොයි හරි දාලා මේ දෙක එහෙමද ඔය වල්ලා මාරේ right at least whatever side even right horizontally no space के लिए दान ना देने वाला important point जो मैनेजर के वो यार उनको करा if you at least writing with the next question you can this you can use to line like this you can place like that उतना कैसे भी ऐड करें we're done with this sometimes this might confuse these things to properly understand it. Very good. Now, we'll move to the next one. What is the next one? What is covalent radius and Van der Waals radius? And what is metallic radius? Right? Those things are there. What is Van der Waals radius, metallic radius, and covalent radius? This is a very easy topic. This is an easy topic. What is the idea? For example, Buddha, we'll take iodine. You know iodine? We take the iodine, I2. In this I2, iodine is like this. Iodine and iodine. I. This is connected like this. This one molecule. This is one molecule. Iodine and iodine. Right. We'll think it means if you take I2, there are lots of I2 molecules. Take I2. There are lots of I2 molecules. Right. So I'm just considering only two of them. I'm just considering only two of them. This is one iodine, this is another iodine. Right. This is the molecule. Now, whatever the distance between, what does it mean? I and I, what I have meant by that? Two iodine molecules like this, they have joined together. This is the meaning of this compound. The meaning of this. So this is the bond between iodine and iodine. This is the bond. So this one is known as covalent bond. With this bond is what? Covalent bond. Already you know that word. Covalent bond, ionic bond, kind of words you know in your O levels itself. So this is known as what bond? Covalent bond. Meaning the covalent bond. This covalent bonds radius. Covalent bond radius is this covalent bond. This radius is known as what radius? Covalent radius. Covalent bonds radius is known as what? Covalent radius. How you see covalent radius? There is a distance from here to here. Here there is a distance. So we are taking this distance half of the distance. Covalent radius is equal to this d divided by easy. Over there, maybe. This is covalent bond. The distance between covalent bonds, half is known as covalent radius. And this is diameter. Okay. Good. Now, now what is this Van der Waals radius? Van der Waals means you have to consider the same molecules, different molecules maybe, but same molecules. Right? Between the same molecules, this what? The connection between this and this, there is a connection. This and this, there is a connection. And this is only known as, in the way, this is only known as what? This is only known as this distance between this is covalent radius is between intramolecule. But intra. This is between inter. You know the difference between inter and intra, right? Know that inter and intra? Intra and inter, don't know. Intra means within. Inter means between. Inter කියන්නේ between, intra means within. So we'll say you are having a competition within in your same class. That is intra-class competition. You are having a competition between your class and next class. That is inter-class competition. That is only intra and inter. Between කියනකොට inter, within කියනකොට intra. Inter-house sports meet. Okay, right. Good. Okay. Good memories. Now what is this? What we call for this? This is an intermolecular bond. But what is the condition? Both should be same molecule. Both should be same molecule. With same molecule on, this is valid. Yeah? So this distance, if I take this distance as capital D, if I take this distance as capital D, take this distance as capital D. So van der Waals radius, van der Waals කියන්නේ not matter van der Waals. Van der Waals. Van der Waals radius is how much? How much? D, capital D divided by van der Waals radius. So did you understand what is now covalent radius and the van der Waals radius? So you think which radius is big? BDW radius or covalent radius? And this van der Waals VR. This van der Waals radius is big or covalent radius is big? Which one will be big? Which one is big? Which one is small? What is too close? Intra on the too close, inter on the too close. Normally, intra on the too close. Normally, intra on the too close. Inter will extra close now. Even close tamai, but not. They are normally you are close within your siblings or your cousins. Cousins la close suna. Love will not the matter. Cousins la your siblings la. What? Cousins la close. Only ka kiano. Then cousin kenek kavilla we malli tayilla gahan. What a article araya. දෙන්නම ගහ ගන්න. මල්ලිත් ගහ ගන්න, ගසෙනුත් ගහ ගන්නවා. එතකොට කාටද වැටීම දුක හිතේ? කාවවත් නැහැ. ගසින්ව වලද මල්ලියෝ. normally. චරවා ගහ ගත්තත් මල්ලිත් එක්ක ගහගෙන නම් කිව්වේ. Tell the truth. ඇත්ත කියන්න ඕන මොකද්ද කියන්නේ කියලා. Don't have shame. Think yeah, no. Huh? You didn't understand the question? Hey, what is my question? Your cousin and your sibling is fighting. So, whom you will feel more sympathy? For a sibling or for your cousin? You just imagine both are same age. But they're nothing, right? Like normally, most of the time you're good with cousins too. The cousins like most of the secrets same nothing. Will you tell everything to your siblings or cousins? Like generation Alutila, I didn't know. Shirav name was that. Name of the land. Most of the people tell are Comrade in there, a counter, a cousin getting no. Yeah, I know every cousin. A cousin getting no, cousins last sick a cousin kid. What about while a area? Other about that key and one Narakat key and up party at a key. Right? Jalmat at a key. I may have more cousins of my siblings taking and then one more. Right? Jalmat at a class of bunker, you know. And you take a matamart to him. Right? So they never agreement at the end, but Math Karam, right? Go out, My question is mostly mostly secrets was please. But more cousin cousin sibling කෙනෙක් ගොඩක් දුක හිතෙන්නේ. That's nature, right? ඉතින් එහෙම සීන්නක් තියෙනවා. Then මොකක්ද මේ එනිසා intra bond is closer than inter bonds. ඒ නිසා covalent radius is which one then short? Covalent radius should be shorter than van der Waals radius. Like van der Waals distance should be more. Van der Waals distance is more than covalent distance. Therefore, van der Waals radius is more than covalent radius. In the make clear. In the lecture, you should know what is covalent radius, what is van der Waals radius, and which one is more. More clear. Right. And then right. Huh? Shall I? No, let us still write this. Interaction between any two bonded adjacent atoms. Interaction between any two bonded adjacent atoms in a molecule. Adjacent atoms in a molecule. Any two bonded adjacent atoms in a molecule is known as covalent. Is known as covalent bond. It's known as covalent bond. Okay. The distance between the bond. The distance between the bond is known as. The distance between the bond is known as covalent distance. The distance between the bond is known as covalent distance. Half of the covalent distance is covalent radius. Half of the covalent distance is covalent radius. Half of the covalent distance is covalent radius. So you go to the next one. When now we spoke about this, finally we'll draw this. Finally we'll draw this. Van der Waals layer. Right? Non-bonding. These are not bonded. Non-bonding bond. Non-bonding atomic. Non-bonding atoms. Interaction. Non-bonding atoms interaction. Is non-bonding atoms interaction just your non-bonding atoms bonding equivalent atoms same atoms non-bonding equivalent atoms non-bonded equivalent atoms unbonded equivalent atoms interaction is van der Waal, van der Waal, van der Waal interaction, van der Waal interaction, van der Waal interaction. The distance between the non-bonding atom, the distance between the non-bonding atom, the distance between the non-bonding atoms is the distance between the non-bonding atom is what? The distance between the non-bonding atom is van der Waal distance. 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 Van der Waal radius is half of the van der Waal distance. Van der Waal radius is half of the van der Waal distance. Beautifully write these things. Use colors. Now, fully understood. Simple D, capital D. Van der Waal. You write full word and you don't write PR, CR, here. I think Cristiano Ronaldo. Cristiano Ronaldo. Covalent radius and PR क्या है? Van der Waal radius. Okay. What is it? PR. Yes. Any lesson that. And we have, you can use the next page. Next page, they would have a lesson that we have only about metallic thing, only about metallic radius. Right? We have write only about metallic radius. So metallic radius to the we can for metallic radius you can use that little bit amount. No need much of that for metallic radius. Covalent radius, van der Waal radius, pretty less. Right. Done. Now you know what is covalent radius, van der Waals radius, those things. Okay. Finally, we'll speak about the metallic radius. Right. Finally, we'll speak about the metallic radius. Then metallic radius mean normally metals. When you take metals, in bonds we will see it thoroughly, right? About metals. Now here, when you take metals, these metals are arranged like this. One after one. These are arranged like this. Metals are arranged like this. This one. So now these are, this is sodium metal here. These are sodium atoms. So what is metallic radius? Mean there is a nucleus, no? There is a nucleus here. So the distance between this nucleus, the distance between the nucleus of adjacent atoms in a metal is known as metallic radius or metallic distance. Radius. This is radius. So half of this. You can see here this is radius is only this much. This metallic distance. So radius will be half of this. Very simple. Even this is the metallic distance. Half of the distance is what? Metallic radius. May have 50 topics. But you shouldn't forget. Okay, what? The covalent radius. Van der Waals radius. Van der Waals. Right. So don't get scared. Van der Waals means what? Intermolecular distance. Covalent means intramolecular distance. So here, this also we can say what? Metallic radius. So metallic distance. So metallic radius is how much? Metallic radius is metallic radius. Metallic radius is equal to what is metallic radius? Metallic distance. Metallic distance divided by distance divided by. You have to. Is it clear? It's like this. Like this. It's kind of like it's all compact. These are compact. Therefore, cap में say negligible. So actually, there is no gap between this. Like very negligible gap. Yeah, I clear? But then write like this. We didn't write any topic. Just you can write like this. The bond distance between the bond distance between the nucleus of two adjacent atoms. What did I tell? The bond distance between the bond distance between the nucleus of two adjacent atoms between two adjacent atoms is known as metallic distance. Yes, metallic distance. The bond distance between the nucleus of two adjacent atoms is known as the bond distance between the nucleus of two adjacent atoms is known as the metallic distance. The half of the metallic distance is metallic radius. The half of the metallic distance is metallic radius. The half of the metallic distance is metallic radius. Make hurry. You understood what is metallic distance, metallic radius, right? Now, many other